This could be one of my best ideas or one of my worst ideas, and I don't think we're gonna know which one it is until we build it and try it out. This is literally a pocket rocket, and I've seen fold-up versions and I've seen flat pack versions, and I wondered if it would be possible to build a small but useful, fully assembled rocket stove that's always ready, doesn't weigh very much, doesn't cost a lot, and it would be capable of cooking something as well. So let's prototype one in plastic first, and we will build it to find out. The most basic rocket stove has a hopper for feeding in the fuel, which is usually sticks or kindling in a small stove. And there's an air inlet, usually at the front. And where the fuel meets that air, we add heat and we'll have a fire. And when the fire burns, the hot exhaust gases go up the chimney and more air is also drawn in, which keeps the fire going strong. Now, a rocket stove is more efficient than a standard fire because the fire burns hotter and there's a lot less smoke because there's a more complete burn. In the best designs, we can even have a secondary burn, which is the ignition of flammable gases released from the wood, and that produces even more heat, and it also produces an even cleaner burn. So we should be able to use sticks and twigs, and because unlike a standard fire, it burns from one end only, it prepares the wet wood by heating and drying that wood before it enters the burn zone. This basic design has some issues though, like how to remove the ashes, and it's a bit rudimentary and clunky. So I designed one which solves some of those issues. The main one being trying to get this thing as small as possible so it can fit into a backpack in one piece. In my design, the hopper is separate from the air intake, and I have a door at the front which allows us to cut off air coming in with the fuel. It also helps me to put out the fire when I'm all finished. The hopper is set at an angle, so we still have an automatic feeding as the fuel burns, and now the burn chamber is directly below the chimney, which means that removing the ashes should be automatic. I have a slightly narrowing chimney, which causes the exhaust gases to speed up as they rise. It also lowers the center of gravity slightly, so it's a little bit more stable. I also just really like the looks of the wider base, even though the angles really complicated the design. I've also included a very simple choke system to adjust the flow of air, and again, I can completely close it off to stop the burn process, just like the door. Even though this is going to be metal in the final product, I think this is where 3D printing can really help out a lot, because we 3D print these parts, these are really inexpensive to make, but we can solve a few issues before they actually come up. One being the size of this, because this needs to be small, needs to fit into a backpack, it needs to be easy to transport around and lightweight as well, but it also needs to be functional. If it's not functional, it's not any good, at least in my opinion. As far as the door wants to open, it's pinching up at the top here. So I made a little mistake there in the design, and then also the handles that are at the bottom and the handle on the door too. I'm going to beef them up just a little tiny bit, and there's also some other little refinements too. And this is 1mm thick stainless steel, and I just wanted to make sure that those pieces would fit together, and you can see they fit really nicely. There's very, very little movement. I wanted just a little tiny bit of play there just to make sure everything would come together okay. So it's time to make our parts, and this is the material I like to use. This is 400mm by 400mm. It's 15 3/4 by 15 3/4. 1mm thick stainless steel. This is 304 stainless. The reason I want to use stainless steel is because then this could stay outside all year long. And the other thing is, when it's really hot, I can just completely soak it with water and not have to worry at all about it. So I'm going to load this on and then we can start making our cuts. I don't really like the way that's looking. I think some of the pieces are going to fall on an angle, so I'm going to add one more support in, and hopefully that stops that from happening. I have the air saver nozzle installed, the one with the ceramic tip there. All we need to do now is calibrate the capacitive sensor. So basically it's going to come down, it's going to touch the top of the material, and that way it sets the machine in relationship to the top surface of the material. It can detect collisions at the point where it would touch something on the side of the nozzle. Okay, we're ready to go. All right, so this is going to be the very first time that I'm going to be welding with this. The weather really hasn't been cooperating. It's been winter. I'm just going to put 2 tacks down, one at each end. We're going to get the position. I can get my finger away from there. And then I'll finish off with an entire small fillet weld, hopefully. Yeah. So let's have a look at. Wow, that's actually incredibly strong. All right, that's a problem. Oh, wow. Okay, well, that's not going to work. So I can't weld right against the surface of it. Something. Oh my God, that's hilarious. Okay. Well, it looks great on the other side, aside from the huge bend. Okay, I think this is going to work awesome. Okay, I think I'm ready to weld. Everything's been tacked up, and it's actually pretty solid as it is. Oh, I forgot. I forgot. Phew, I'm lucky. That was about 10 times easier than I was expecting it to be. It's a little bit more difficult than super gluing some plastic together, but really not that much. I was able to weld almost every single seam. I did struggle a little bit in this V shape down here, and then I struggled to weld the chute top and then the front panel together too, because it is so deep into there. I probably should have done that first, thinking about it now. So let's go find some wood and we can test this thing out. I'm gonna make one more part that I can insert into our tiny rocket stove. And that's because I'm not really too happy with the way the ashes are forming and the coals are forming. It seems to be blocking the airflow from the bottom. So hopefully this new part will help with that. So wet sticks, not really a good idea. And also big chunky sticks like this one that fill up the entire chute, also not really a great idea. So I have some kindling and I wanted to try to see how that did. This is also fairly dry, not perfectly dry, but definitely better than the wet sticks I picked up off the ground. And it happens to be raining today, so this is kind of the perfect test. Not bad. It worked really well with this firewood that I split up into small pieces, small enough to fit into the chute, but obviously they stuck out really far. So overall, the construction of this worked out really well. All of the welds held together perfectly. So this is the second rocket stove that I built, and the design is fairly similar to the first one, except for the first one was a full-size rocket stove. It's probably about 5 times the size of this one. So I didn't have any problem putting in quite a few pieces of wood into my original one, and because of that I was able to generate a lot more heat, and I was also getting a lot less smoke out of the top of my original rocket stove. In this one here, I think because I'm only able to put a few pieces of wood in there, I wasn't able to generate very much heat. I was getting a lot more smoke, but there was also a little bit of an issue with the air as it was being drawn in. So my design here, maybe not the best design. For example, the choke here, not really that functional because it was getting really hot. As you feed the lumber in, it burns back and it just stays there. I would need to push it in, and I don't want to have to do that. So this needs to be up on an angle somewhat like this, or even more vertical, in order to be self-feeding. The size of the chute needs to be increased, probably increased in the width, but maybe in the height a little bit as well. I'm not sure about the chute door, whether it's even necessary, because most of the time I had this working with it kind of like this, and that seemed to work okay. It might be possible if we add an insulating layer around this exhaust pipe here, the exhaust would come up into that insulating layer and then maybe either come out the back or then come up again and exhaust out the top. Building a tiny and functional rocket stove comes with a set of challenges, and it's hard to know what those are going to be unless we go ahead and build one. So this is version number 1. I've already started on the design for version number 2. I will have a larger self-feeding hopper. It also accommodates longer pieces of fuel. It also will have an insulating layer around the chimney for better heat retention and also hopefully better combustion, which also acts as a stable surface for pots and pans as well. I have a much longer partitioned chimney for a better secondary combustion, and I've moved the air inlet back to the front, which is probably a better place for it, and that also helps with keeping that front area quite cool. I do still need to work on a few little details like the stability, and also need to see if this actually will work at all. So before I go ahead and build one, if you have some ideas that you'd like to see in the next design, please let me know in the comments down there. I had a lot of fun creating this little guy. I think the tack welding though was my favorite part. Being able to put these pieces together quickly and accurately made a huge difference in the success of this project. And considering how small this was and the tight spaces that I had to get into, welding anything else should be a piece of cake. Easy enough that I'd like to get started right away on the improved version. If you've been eyeballing the tool that allowed me to bring this idea to life, the 1200 watt welder and CNC combo called the xTool Metal Fab. xTool has a spring sale on right now with savings up to $2,900. The bigger the purchase, the bigger the savings, and I will link that down there below if you're interested. I also have a few more videos showing off what this machine is capable of, and I will link those up above there if you'd like to check those out. As always, I'll link my top 3D printer picks down there below if you're interested in those too, because plastic makes perfect, and printing parts in plastic first gave me the confidence to make the parts in metal. Thank you to my patrons for helping to make these videos possible, and thank you for watching. Take care, and I hope to see you on the next one.